Okay, so now let's talk about what I actually think is the most technically interesting part of this entire platform. And it's frankly the piece that doesn't exist anywhere else in the market right now, and that is the Orbital AMM, which is basically the source of the interest and sort of liquidity and returns that we'll be actually generating. So, if you want to read a pretty good guide that gives you the overview of kind of the mathematics behind how this functions and kind of why it's relevant and important, you can read this little guide right here. But basically, if you have any experience with sort of crypto decentralized exchanges or AMMs, automated market makers, you know that basically AMMs work by defining a mathematical invariant, which is basically a curve that governs the relationship between two assets in a pool. So you may know of Uniswap, which uses a constant product formula like x times y equals k. Curve uses more of a hybrid stable swap invariant optimized for pegged assets. And these were great for, fungible, freely tradable tokens. But the difficulty that basically I'm solving for here is we're not dealing with freely tradable tokens. These are ERC 1404 restricted securities. So every transfer has to pass through our transfer rules contract. Every counterparty has to be whitelisted. You can't just dump these into a Uniswap pool because the pool contract itself would need to be a verified participant, and there's no way to KYC or verify a piece of code on a blockchain. So basically the compliance surface becomes completely unmanageable. And so that really is the core liquidity problem with most on-chain securities. So I basically built the Orbital AMM from scratch, and instead of using a two-dimensional curve, we use a sphere invariant. Kind of think of it like a three-dimensional constant product surface. The invariant is x squared plus y squared plus z squared equals r squared, where the third dimension encodes the compliance state of the liquidity. So in practical terms, what does that mean? This AMM natively understands that not all liquidity is equivalent. So $1 of liquidity from a fully verified accredited investor has different reachability than $1 from, say, a Reg S foreign participant. The sphere surface lets us partition the liquidity by regulatory jurisdiction without fragmenting the pool into separate silos, and that's really critical. So basically, right now, what you're looking at right here, which is one of these examples of a pool. Actually, it'd be probably best to just create a pool and show you what I'm talking about. So we're able to do multi-token pools up to actually 8 unique assets per pool. And basically, it's really an efficient way of concentrating liquidity at one price point on the sphere surface. So basically, the importance of this is when you have a three-dimensional trading pool or surface, you're able to basically choose where you're concentrating your liquidity, and that in turn dictates how these assets are basically related and priced with one another. So just kind of talk through an example here. Actually, I don't really have any tokens, but I'll see if they'll let me just do this randomly. So let's see. Okay, cool. So this is where you would configure the concentration power. So there's a kind of range of spreads or concentrations that you can choose from. You choose broad, which would basically be like a wide liquidity spread for super volatile uncorrelated token pairs. So that would be your least concentrated power. And then that goes all the way up to ultra tight, which would be for tightly correlated or pegged assets like $1 to USDC or whatever you wanted to basically pull together that are incredibly pegged and dependent on one another. So the higher concentration focuses more liquidity near the equilibrium price, which is what increases capital efficiency. So if you look at this little graph down here, you see the broad, it's the liquidity distribution is more spread out, whereas with ultra tight, it's dead kind of in the equilibrium price, like that's where all the liquidity is pooled at. And because of this kind of range of configuration that you can choose with these pools, there are different fee tiers that you can choose to configure for your pool that you deploy. So if it's a high volatility, you might want to charge a higher fee to kind of undo some of the impermanent loss that can happen in deploying these types of pools. So you could choose for a high volatility, say broad concentration pool. That would be how you would configure that, and then you would need to essentially deposit the initial liquidity for this pool, where you would deposit certain amount of the different assets that you're trying to basically pull together, and then that would set the initial power mean invariant for how the liquidity is concentrated in this pool. So basically, let me think, what else would be important to talk about? This specific implementation of a basically automated market maker, in comparison to what's really on the market right now in most Ethereum dexes and things, these transactions cost hundreds of thousands of gas per each swap. So basically what I decided to do was I used a sort of a really cutting edge coding language called Stylus, which essentially takes a hybrid architecture where a lot of the math and more heavy computation that's happening with these invariants is actually happening off chain. So you're not paying for the compute on the blockchain, which makes an insane amount of savings in terms of the actual cost of interacting with these pools, and just makes you save money and actually gain more, not eat into your actual return, more so than traditional dexes would. So basically, what happens when a liquidity taker wants to initiate a swap in this scenario? Basically, the transaction hits the restricted swap contract, which is part of the security token that we deployed, which directly calls into the transfer rules contract, which verifies that both the taker and the pool's liquidity providers are eligible counterparties for this swap or transfer. And then if the provider in the active tick, which is basically the trade that's trying to happen, isn't eligible to transact with that specific taker, say it's like a US person trying to swap into a Reg S, and they are not allowed because it's for non-US investors, basically the liquidity would be excluded from that calculation. So this whole computation happens off chain, which is again saving you and having to have a failed transaction that does cost gas and will lose you money. So basically, if all the parameters of the swap are found to be true and accurate and able to be executed, the orbital pool basically computes the output amount against the sphere invariant, and then uses only the eligible liquidity that's been approved through the transfer restrictions and restricted swap contracts, and then executes an atomic transaction where basically the transfer fires with all of the compliance metadata. So the important part is the compliance check, the invariant math, the transfer restriction enforcement all happens in one transaction, a single atomic transaction. So it's not like there's an off-chain matching order book. There's no reliance on a centralized order router. It's fully on-chain, fully auditable, fully composable with any other DeFi primitive or any other, like a trading sort of venue or mechanism on-chain. So the composability part really matters because these pools emit standard events and expose standard interfaces. So basically, protocols can integrate with these pools and have audit trails and have like a clear sort of accounting of what has been generated on the trading of these assets. Again, these are securities, so it's really critical that there is absolute transparency and clarity in terms of like what's actually happening with these assets as they're trading. So that's the Orbital AMM.